Hi folks, video on perpendicular lines. Just make sure you have your notes in front of you, and you'll need your jotter or a bit of paper as well to work from. But if two lines are perpendicular, the product of their gradients will be -1. So if we multiply the two gradients of the lines together, we get -1. And just so we know what I'm talking about here, I'm just going to draw two lines that are perpendicular to each other. So if two lines are perpendicular, it means they meet at 90 degrees. So they have a 90-degree angle in between them. So two lines here meet at 90 degrees. So the two lines I've drawn there, if I was to take the gradient of this line and the gradient of this line and multiply them together, I would get -1. So what we're going to start off by doing, I would encourage you to use your jotter for this and do it along with me. But I have two diagrams, and we're just going to investigate this idea of perpendicular lines and their gradients. In each case, the lines that I've drawn in each diagram are perpendicular to each other, so I'm telling you straight away that these lines are perpendicular. I'll just draw the wee 90-degree in as well. Okay, and then this is just to show you that this is the case. This M1, M2, the two gradients multiplied together give you -1. So if I was to look at these two lines here, so we've got L1 is the blue line, L2 is the red line. So what I'm going to do is I'm going to go ahead and work out the gradient of each of these lines. So the gradient of L1 in the first place, this is using my y2 minus y1 formula. You could pause the video and have a wee go yourself and just make sure you get the same gradients as I do. But just save a wee bit of time. 5 subtract -1, that'd be y2 minus y1, and that's over x2, which is 3 minus 1. So that comes out to be 5 subtract -1 gives me 6. That's 5 add 1, which is 6, and 3 take away 1 is 2. So it's 6 over 2, which simplifies to 3. So there's the gradient of L1. Do the same thing now for the gradient of L2. So y2 minus y1. Just remember this point here, 6 would be 6, 0 as a full coordinate. So 6, 0. So if I call this my second coordinate, I get 0, subtract 3. Remember, when you do this gradient formula, you can have your coordinates either way around. And then x2, 6, subtract x1, which is -3. So 6 subtract -3. If I go and simplify this, I get -3 over 6 subtract -3 is 6 add 3, which is 9. Which comes out, if I simplify that down, comes out to be -1/3. Then I can perform a wee check. So if the lines are perpendicular, when I multiply the gradients of each line together, I should get -1. So let's have a wee look. So M1 times M2 would be 3 as our first gradient multiplied by -1/3. Well, this is a positive and a negative multiplied together, so my answer is going to be negative. And then 3/3, 3 times 1/3 would give me just 1. So that works out perfectly. So these two lines are definitely perpendicular. And then for the second one, again we're going to do the same thing. So we have two lines, and I'm going to work out the gradient of each line. Again, I would advise you to pause the video at this point, see if you can work out what the gradient of L1 is and the gradient of L2 is. See if you can remember how to do that. But to start off, I'm going to do the gradient of L1. Now, to work out the gradient of a line, I know I can use either, it's going to be y2 minus y1 over x2 minus x1. However, to use that formula, I require 2 points on the line, which I don't have, so I can't use that formula. The other formula we've looked at so far is m equals tan theta. So, and because we're dealing with an angle here, this is going to be a tan theta question. So it's a good wee callback to a couple of lessons ago. So m equals tan theta. Now we know this is the blue line, L1. So we always look to the angle above the x-axis, but to the right of the line. So this angle in here, which is the angle we're given. So that's perfect. So tan of 60. And as another wee check, I can just say, right, that line is sloping upwards from left to right. therefore it must have a positive gradient. So it's just another wee check you can do to make sure your answer definitely does make sense. And right now, eventually you'll be able to work out things like tan of 60, but at the moment you can just use your calculator. So tan of 60 comes out to be root 3. And I'll just keep that as a surd right now. Okay, so go ahead and work out gradient of L2 now. So again, same thing, I don't have two coordinates, so the only other way I can work out the gradient at the moment is to say it's tan theta again. Now this time the line is sloping down the way from left to right, but I still want the angle to the right hand side of the line above the x-axis. So if I'll do this in green, so I'm looking for this whole angle here, all the way around to the x-axis, which is an obtuse angle. So to work this out, I know this is 60 up to the blue line, and then 90 more after that, so it's 90 plus 60. So my overall angle is going to be 150 degrees. So this is tan of 150 degrees. Again, eventually you will be able to work out what tan of 150 degrees is, right? But right now, what we'll do is just fire it in the calculator. So using your scientific calculator, you'll either get, I think your calculator will probably give you out as negative root 3 over 3. You'll get like that, which is fine. Okay, and then from there, again I'm going to try this, multiply the gradients together and just see what I get. So gradient of 1 multiplied by gradient 2 is equal to, well, that's root 3 multiplied by negative root 3 over 3. Wee bit of surd rules coming in here. So I could think of this root 3 as root 3 over 1. So multiplying the fractions, overall it's going to be negative because I have a positive multiplied by a negative, so my answer is going to be negative. And then fraction times a fraction, multiply the tops together, so it's root 3 times root 3. If you remember your surd rules, that's just 3. And then 1 times 3 in the bottom, which is 3. And that simplifies nicely to negative 1. Okay, so we know they're perpendicular as well, and we can see from the diagram that those two lines were definitely perpendicular because I've drawn the 90 degree in, and we still get negative 1 out. So a nice important result for perpendicular lines. Their gradients, when you multiply them together, give you negative 1. And the other thing that we could do if we were told a gradient of a perpendicular line, if we knew a line was perpendicular to another line and we knew one gradient, we could use this formula to work out the missing gradient by just substituting the gradient we know in. So what we'll do is look at some examples now. This is on page 5 of your notes. In each case, I want to calculate the gradient of the lines perpendicular to these gradients. There's a really quick way we'll see how to do in a second, but we'll follow our formula first, see if we can spot it. So beginning, if we have a perpendicular line, well, I know that gradient multiplied by its perpendicular line gives you negative 1. If one of these gradients is negative a seventh, then it's negative a seventh times the second gradient equals negative 1. And then I want to rearrange to get m2 by itself, so the way I would do that is multiply both sides by 7, so I would get negative 1 times m2 equals negative 7, and then divide both sides by negative 1 to get rid of the negative, so m2 equals just 7. Same thing again for part B, so starting again with m1, m2 equals negative 1. Sometimes I won't write the multiply, but 2 beside each other still means they're multiplying. So I know one of these is 5 now, so I'll make that 5 times m2 equals negative 1. So to get m2 by itself, I just divide both sides by 5, so it's negative 1 over 5. There we go. And each time I want you to compare the gradient we got out compared to the original gradient. So negative a seventh to 7, 5 to negative a fifth, and then continuing on. So m1, m2 equals negative 1. If one of our gradients is negative 2 over 3, then it's negative 2 over 3 times the second gradient would give me negative 1. because they're perpendicular. So rearranging for M2, so if I multiply both sides by 3 first, I get negative 2M2, the 3 disappears to give me negative 3, and then divide by negative 2, so M2 is equal to negative 3 over negative 2, and the negatives will cancel, so just 3 over 2. So negative divided by a negative, just give you a positive. Awesome, so again, comparing negative 2 over 3 to 3 over 2, maybe see what's happening here, each case. And then for the final one, M1, M2 equals negative 1. 3 over 7 is one of our gradients, so 3/7 M2 equals negative 1. Let's see if you can guess even what this would turn out to be, if you can follow the pattern. But continuing mathematically, so multiply both sides by 7 first, so 3M2 equals negative 7, and then divide by 3, so M2 is negative 7 over 3. There we go. Okay, now hopefully you've spotted that in each case, to get the perpendicular gradient, all we do is we flip the gradient, so 1 over 7 becomes 7 over 1, or just 7 in this case, and we make it negative. So if it was already negative, your answer becomes positive. So you flip and change sign is the quick way of doing it. Flip and change sign. Now, if you're extremely confident doing this, then that's fine to use this flip and change sign. This is what I would probably do if I was doing a question. However, if you're not super confident at the moment, I would continue to use your M1, M2 equals negative 1 until you get that understanding. Okay, but the quick way would be flip and change sign. So again, if I have another gradient, let's say I have 5 over 6, to get a perpendicular gradient, if that was M1, then M2 would just be flipped, so 6 over 5 now, and make negative. Okay, and again, if I take another example, gradient equal to 1/10, then M2, if I just flip it, it becomes 10 over 1, but then becomes negative, so negative 10. And remember, 10 over 1, I can just simplify to be negative 10. So that's a quick way of doing it. Now, on example 2, this is slightly different again, but the same idea. So the line with equation 2y equals 5x plus 7 is perpendicular to the line with equation y equals kx. Remember, k in this case would be our gradient, y equals mx. So k is our gradient. So if it's perpendicular, that's your key word there, perpendicular, which is suggesting that if we're talking about lines, then we're going to use m1, m2 equals negative 1. So the first thing to do would be to work out, right, this line I've already got, let's see if we can work out the gradient of the line that's perpendicular to the one I want. Now, in order to work out the gradient, I need to rearrange it into the form y equals mx plus c, so divide both sides by 2. So that's 5 over 2x plus 7 over 2. Therefore, our gradient is equal to 5 over 2. And that implies, or what I'll do, actually I'll do it slightly differently. I was going to do it the quick way, but I'll do it the longer way right now, just for anyone who's not super confident. So once we've got our gradient, I know that m1, m2 equals negative 1. So if one of our gradients is 5 or 2, then I'll sub that in. Therefore, the perpendicular gradient is what I get when I multiply both sides by 2 and then divide by 5, so negative 2 over 5. So k, and I'll just write explicitly that therefore k is equal to negative 2 over 5. Okay. So there will be practice on Teams for you to try as well. And any questions, just let me know.